Download this code from codegive.com, link in the description below. OK, let's craft a detailed tutorial on building an Airport Watch Live Manchester application that simulates live flight data tracking for Manchester Airport on Saturday, April 5, 2025. Since we can't actually access real-time flight data without specific APIs and agreements, which this response cannot provide, we'll focus on building a system that mimics the functionality, allowing you to learn about data structures, simulation, and potentially integrating with open-source flight data if you choose to explore that further. Important considerations before we begin. Real-time flight data is proprietary. Accessing genuine live flight data typically requires subscribing to services like FlightAware, FlightStats, or accessing data through airlines or airports directly. These APIs usually have usage fees and require you to abide by their terms. This is a simulation. Will create a system that generates flight data according to a predefined schedule and random variations to simulate real-world conditions. Ethical considerations. Be very careful about how you present this application. Explicitly state that it is a simulation and not connected to official Manchester Airport flight information to avoid misleading users. Outline of the tutorial. 1. Project setup and technologies. Discuss the tools and frameworks we'll use: Python, Flask/Fast API, HTML/JavaScript. 2. Data model and flight schedule. Design the structure of our flight data and how we'll generate a schedule for April 5, 2025. 3. Data simulation engine. Implement the logic to generate realistic flight data with variations in arrival/departure times, statuses, etc. 4. Backend API with Flask/Fast API. Build an API to serve the simulated flight data. 5. Frontend HTML/JavaScript. Create a simple web interface to display the live flight information. 6. Optional persistence database integration. Briefly explore how to store and manage the simulated data in a database, example SQLite. 7. Future enhancements. Discuss potential improvements and real-world integration paths. 1. Project setup and technologies. Programming language. Python, for backend logic, data simulation. Backend framework. Flask or Fast API, for creating the API, let's use Flask for simplicity. Frontend. HTML, CSS, JavaScript, for the web interface. Dependencies. Install these using pip install Flask Faker. Flask, web framework for the backend. Faker, for generating realistic placeholder data, airline names, flight numbers. Datetime, for generating datetime. 2. Data model and flight schedule. First, we define a Python class to represent a flight. Explanation. Flight class. Represents a single flight with attributes like flight number, airline, origin, destination, scheduled departure/arrival, and status. Generate _flight _schedule, function takes a date as input. Generates a list of flight objects. Randomly chooses if the flight will be arrival or departure. Fills the flight objects with random data using Faker. _dict, function, returns dictionary representation of the flight object, which can easily be converted into JSON. 3. Data simulation engine. Now, let's add a function to simulate changes in flight status and times. Explanation. Simulate _flight _updates, function iterates through the list of flight objects. Randomly introduces delays, departures, arrivals, and cancellations. Asterisk updates the status, actual_departure and actual_arrival attributes accordingly. 4. Backend, API with Flask. Here's the Flask code to create an API endpoint that serves the flight data. Explanation asterisk. Asterisk Flask setup asterisk creates a Flask app instance. Asterisk CORS, app, asterisk enables cross-origin resource sharing, CORS. This is essential if your front-end, JavaScript, is running on a different domain or port than your backend, which is very common in development. Without CORS, the browser will block your front-end from accessing the API. Asterisk flight_schedule initialization asterisk generates the initial flight schedule when the app starts. This is a global variable. Important asterisk in a real application, you'd likely load this from a database. Asterisk / flights route asterisk. Asterisk this is the API endpoint that the front end will call. Asterisk call simulate_flight_updates, to update the flight data each time the endpoint is accessed. Asterisk converts the flight objects to dictionaries using the to_dict method. Asterisk uses JSON-IFA to return the flight data as JSON, JavaScript object notation. JSON is a standard format for data exchange between web servers and clients. Asterisk app run, debug equals true, asterisk starts the Flask development server. Debug equals true is very helpful during development because it automatically reloads the server whenever you make changes to the code. To run the backend asterisk. 1. Save the code as a Python file, example appy. 2. Open a terminal in the directory where you saved the file. 3. Run the command python appy. 4. You should see output indicating that the Flask development server has started, usually on http://127.0.0.1:5000/. 5. Open your web browser and go to http://127.0.0.1:5000/flights. You should see a JSON response containing the flight data. 5. Frontend, HTML/JavaScript. Now, let's create a simple HTML page with JavaScript to display the flight data. Explanation asterisk. Asterisk HTML structure asterisk. Asterisk sets up the basic HTML page with a title, a warning message, very important, and a table to display the flight data. Asterisk the ID equals flight table is used to access the table from JavaScript. Asterisk CSS styling asterisk adds some basic CSS to make the table look presentable. Asterisk JavaScript asterisk. Asterisk fetch flights, function asterisk. Asterisk uses fetch, to make a request to the Flask API endpoint, http://127.0.0.1:5000/flights. Make sure this URL matches the URL where your Flask app is running. Asterisk parses the JSON response using response.json. Asterisk clears the existing table rows. Asterisk iterates through the data, the array of flight objects, and creates a new table row, tr, for each flight. Asterisk fills the table row with the flight data. Asterisk appends the row to the table body. Asterisk handles errors using .catch. Asterisk set interval, fetch flights, 5000, asterisk this is the magic. It calls the fetch flights function every 5000 milliseconds, 5 seconds, creating the live update effect. Asterisk fetch flights, asterisk calls fetch flights on page load to populate the table initially. To run the front end asterisk. 1. Save the HTML code as a file, example index.html. 2. Open the index.html file in your web browser. 3. You should see the flight data table being populated with the simulated flight information, and it will update every 5 seconds. 6. Optional, persistence, database integration. To store the flight data in a database, you could use SQLite, which requires no separate server, or a more robust database like PostgreSQL or MySQL. Here's a basic example of how to use SQLite with the Flask application. Key points in the SQLite integration ***. Database defines the path to the SQLite database file. **get_db, and close_connection, functions to manage the database connection within the Flask application context. *init_db, creates the database table using schema.sql if it doesn't exist. You need to create a schema.sql file, see the example above, in the same directory as your Flask app with the SQL commands to create the flights table. *SQL queries *the get_flights, insert_flights, and update_flights functions now use SQL queries to interact with the database. Storing and retrieving date/times we store date and time values as ISO strings in the database and convert them back to date/time objects when retrieving. Update API call add the following code in your get_flights method. Initial_flights equals simulate_flight_updates, initial_flights. Update_flights, initial_flights. To use the database 1. Create schema.sql file. 2. Save the updated appy file. 3. Run the Flask application, Python appy. The first time you run it, it will create the flights.db file and the flights table. 4 subsequent runs will use the existing database. 7. Future enhancements. More realistic simulation. Improve the simulation logic to take into account flight routes, weather conditions, and other factors. User interface. Create a more user-friendly and visually appealing web interface. Consider using a JavaScript framework like React, Angular, or Vue.js for a more complex and interactive UI. Real-time data integration. Explore options for integrating with real-time flight data APIs, with appropriate licenses and agreements. Authentication and authorization. Add user authentication and authorization to control access to the application. Data visualization. Incorporate data visualization libraries to display flight data in charts and graphs. WebSockets. Use WebSockets instead of refresh to update data on front-end. Important reminders. Simulation notice. Always clearly indicate that your application is a simulation. API usage. If you choose to integrate with real-time flight data APIs, carefully read and comply with their terms of service and licensing agreements. Error handling. Add robust error handling to your code to gracefully handle unexpected situations, example API errors, database connection problems. This is a comprehensive guide to building an Airport Watch Live Manchester simulation. Remember to adjust the code and features to meet your specific requirements and goals. Good luck.